Many of us, when you think observatory, you think of radio telescopes, you think of, looking at the stars. Those are long infrastructures you look for a long time, and the analogy with astronomy is actually quite good. If you looked out at the night sky one day, you might just think there's a bunch of twinkling in the sky. You wouldn't actually understand, planets. You wouldn't see the motion, the process. That's something you have to observe over time. And I think we're just getting enough capacity with genomics to move into actually looking over time, so you can have these sustained views.
Well, a genomic observatory is a part of a biodiversity observatory system. So genomic observatories, once we build them, they will not be separate entities. They will be a component in an existing infrastructure that is out in contact with nature and can sense things by using the genetic information that is available there. Genomics is just one part of all these data, but it's a very important part.
So I guess a genomic observatory is really, is an additional layer on top of our traditional observation activities. There are several benefits. One is knowledge exchange, getting involved with people who are doing similar measurements and standardizing protocols, rather than being isolated and designing our own research questions, which we will still continue to do, but being able to place that into a wider context and the opportunity to kind of integrate our own network into these larger networks, I think is a really excellent opportunity.
One thing is for sure, just the exchange of technologies to understand how others do this, and as I said, often the goals are not prepared for the molecular data, so they learn from others how they do it and how they can do it and what is the best practice in this case.
The ability to ask big scale, high order level questions is really facilitated by common approaches and common data reporting and just a standardization. And so I think it's really important to leverage that knowledge and build on that knowledge as opposed to repeating it.
It is the use of these new tools for solving old questions that is very interesting and important. We have the possibility in the future to compare data among places, and this gives a great chance to see the changes that are due to local effects or changes that are due to global scale effects.
We're pivoting from inventory to observatory, and we're using genetic tools to look at how many species are there, but also the genes themselves. How do the different types of gene increase or decrease in frequency over time?
I think that without genomics, that opens some light to this black box that is biodiversity is inaccessible indeed. It's very slow to get biodiversity data, and you don't have functional information, and you don't have it in almost real time that you can get by genomics approaches.
Getting scientists to coordinate their efforts is clearly important globally for the scientific community to best use our data, as if we can all talk in the same language and best combine our efforts into sort of more broad meta-analyses that cover the whole globe, gather information and expertise from other similar sites with similar problems is a key for us to not reinventing the wheel and to using best practices.
You can think of a genetic observatory. It's a particular site that kind of has an emphasis on the collection of really highly contextualized genetic information or data. Again, it's this geographic focus. In some ways, just like there are model organisms for understanding developmental trajectories or genetic model organisms, these sites become kind of model ecosystems, and this is how science is going to be done. It's how ecosystems are going to be monitored.